From the aphelion and perihelion of each planet in our solar system, we want to construct their elliptical orbit around the Sun in both rectangular and polar coordinates. The aphelion is the longest distance the planet is from the Sun, and the perihelion is the shortest. For example, the Earth's aphelion is 152 million kilometers, and its perihelion is 147 million kilometers. I researched the data corresponding to the aphelia and perihelia of the 9 planets in our solar system. I kept the values to 3 significant figures and expressed them in millions of kilometers. We now adapt our data to the generic figure of an ellipse. I set the Sun to be at the left focal point, a distance c from the center of the ellipse. Therefore, a planet is at its aphelion when its position is the rightmost vertex of the ellipse, a distance a from the center. Similarly, the planet's perihelion is the leftmost vertex of the ellipse. I set the major axis of the ellipse along the x-axis. To find the equation of the elliptical orbits in Cartesian coordinates, I expressed the parameter a and b of the equation of an ellipse in terms of the aphelion and perihelion of the planet. I have recorded the parameter a and b for the elliptical orbits in Cartesian coordinates for all 9 planets of the solar system. I have included their eccentricity. I noticed that most planets are very close to a circular orbit with the exception of Mercury and Pluto. The problem with Cartesian coordinates is that each planet has an elliptical orbit with different centers. The polar coordinates of elliptical orbits place the Sun at the origin for all planetary orbits. The coordinates are now with respect to the Sun. For an ellipse, the eccentricity is defined as the constant ratio between the distance of the planet to the Sun and the distance of the planet to a vertical directrix, p units to the right of the Sun. After expressing the orbit in polar coordinates, I found the relationship between them and the aphelion and perihelion of the planet. Finally, from the aphelion and eccentricity of each planet, I computed the corresponding directrix distance to the Sun. This allows me to express the planetary orbits in polar coordinates.